Hi, this is a quick summary of Exercise 1. We had started Exercise 1 in our Geostatistics class previously. If you look at the modules, you can see I've updated it a little bit. You can see the zip file that'll have the actual ArcGIS profile as well as associated files. I've got this data depth description, layout table, guide, and I have the vital statistics database from where I got these things as well. So you can see where I got a lot of these data from, and so since I put them here and I thought they were important enough to put here, I would just go and download these now for reference, because when you start working with individual data sets, you can start to see all the different types of attributes, information that you deal with that are going to be unique to each and every kind of file, system, organization that we work with. I've got layout table right here. I'll download this. This might be slightly different. And so you can see something like this. It says occurrence. We have race of decedent, 1, white, 2, black or African American, 3, American Indian, Alaska Native. And so you can see what all of these attributes are actually going to represent. I've got another guide here from 2016 because there was a schema change between the two. And so we can see this will get specifically into some of the different states and dates and all these other things here. But when we go back to this exercise here, we're going to be sitting right here at ArcGIS Pro. This is where we were sitting. I'll take a couple minutes to kind of go through some of the finer points that perhaps we didn't cover last night. But in the left, we have the table of contents right here. This is called the table of contents. And you can see I've got a map, because I can go insert other things besides maps. I've got graphs, I've got charts. A layout is going to be an actual map, and we're going to work with layouts in this exercise as well. And within these layouts, we can insert other elements. We have legends that we can work with as well. I can check and uncheck these cancer deaths, because like we alluded to last night, when we look at these cancer deaths, they get really ugly really quickly. We're looking at more than 100,000 of these cancer deaths that were taken, over a period of time. And then we have counties, and then we have what we call a base map underneath here. And these are relatively new with ArcGIS Pro. And so this button up here at the top, I can change my base map. Instead of being, street map or navigation map or topographic map, I can change it to say, imagery or something like that. So you can see, the latest and greatest imagery that we have here as well. So there's a lot of different options that we can, that we can do here. But I've just kind of changed it to like a world street map or something like that, since it's, to be honest with you, it's not all that important. And so we've got our cancer deaths, because we're going to be mainly focusing on this as well. We talked a little bit about the select by attributes, and we'll go back and revisit those when we start looking at some of the exercises. But when we zoom in, we can zoom into these individual deaths right here. And so I can literally click on one of these points, and we can look at the information about these here. Now we have an X and a Y, and this was part of the geocoding process, but we have things like sex 1, race 1. And so what I can do is refer to some of these documents here that says, all right, what does the sex mean? 1 is going to be 1 male, 2 female, 9 unknown. So we can start to look for differences between males and females, and in addition to what we looked at yesterday a little bit with the age. I can click on, we have the ICD codes right there, so C349, we can see what C349 means. And so while I'm kind of highlighting those here and I'm giving you a chance to go through these, I can kind of look at some of the ICD code lookup. And so there's a lot of ICD codes out there. So I can say, oops, I'm sorry, going a little fast here. So I can go to something like ICD list, and you can see 349 or 34.9, neoplasm, unspecified part of, lung. There's a lot of these that we have to look up. So if you want to look up specific causes of death or specific types of cancer, those are, there's some options for us to go and do those. But when we look at the homework, we have a little video here on kind of an introduction to spatial data science. And so I've got a nice video right here about what we're kind of learning about, why we're learning about it. Geostatistics is, relatively new compared to the whole world of GIS. And so the biggest investment in data analysis, this is something you can kind of play in the background. I've got a couple questions attached to this. Also, I have a couple questions attached to the Introduction to Quantitative Geography. Introduction to Quantitative Geography that's sitting in our modules right here. I really like this introduction just because this kind of talks about how quantitative geography came to be. In the 60s and the 70s and the 80s, we had something called the quantitative revolution. There's been a couple of really neat papers on those, and it probably doesn't mean a lot to a lot of people, but those of you a little bit more interested and invested in GIS will see the value in the difference between just making maps and doing some of this geostatistical analysis and really supporting theories. Supporting theories. All right, so let's start working on the exercise. And I'm not going to answer the exact questions, especially when we start doing some of these that we got into. But what's the geometry type here? And we'll just kind of revisit these here. The geometry type for for cancer deaths is points. Okay, the represented as points. But other ways that we can look at this is I can right mouse click, and we already looked at the attribute table here, but I can go down to properties, and this gives me the properties of NC cancer deaths. And I can click on source, and I can see geometry type. It tells me point versus counties. I can go to properties, and you can see it tells me that it's a polygon. There's a lot of different geometry types. We have different data models that we have. So we have vector data, we have raster data, we have things called TINs, we have standalone tables. We don't do too much work with these different types here, but we will kind of revisit. We will revisit these some of the raster data as we get a little bit more into the this class when we look at predictive surfaces and interpolated surfaces, which I think is pretty neat. But we've got a point right here just so we can see this, but it's got the name, object IDs, a lot of the things we don't care about. These are the things that I care about. Once again, I'm not going to go through and start counting all these individual points, so I can right mouse click, open attribute table, and then I can see down here I've got 102,699 individual points sitting right here, and there's a one-to-one relationship between these points and the features on a map. That's what makes a GIS. So I can click on point number 3, and you can see that it's highlighted right here as well. So my next question gets into the attribute race. Refers to the race of decedents using the codes in the layout table. What percent of decedents within the entire state are white? And then remember, when I went into these layout tables, you could see these layout tables here had sex 1, that was for sex. There's a race 1 here somewhere. I want to make sure I've got it in the right place here, where I'm getting my information from here. But when I start to look at race here, race of decedent, 1 white, 2 black or African American, 3 American Indian or Alaska Native, 4 others. So I just want to find everything that's where the race field is going to be equal to 1. And so this isn't going to be a spatial query. This is going to be a tabular query or a spatial query. So once again, we're going to look at select by attributes. We're in a new selection, and let's just go through and look for the attribute where I'm going to find something that highlights race. Let me look for race right here. Race is equal to, and I go to the drop down, and it has all these possible values right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to click on 1. I'm going to click apply. And you can see 80,542. The question answers for the percentage, so we can do some simple math right here to calculate this percentage here, which is going to be probably a little less than 80% or so. Okay, but I'll let you go through and calculate those. And so here we're using the DDFs. These are called data dictionary files that tell us what each of the attributes represent, and then turning these into kind of useful information. We had the race age units. So what percentage of decedents are under the age of 30? What percent of decedents were between the ages of 40 and 60? So we'll go back and revisit those. Now this is going to be an entirely new query here, because when I go to this drop down, I can do add to current selection, remove from current selection, select subset from current selection. So we're going to create a brand new query. So I'm going to add a new clause, and I'm just going to say age units is less than or equal to 30. And I'm going to click apply. This is an entirely new query, so now we can see 841 of 102,699, and all we do is calculate the percentage. The percentage should be a number between 0 and 100. And so this is for under the age of 30, and then we looked at between 40 and 60, so it is greater than or equal to 40, and age units is less than or equal to 60. Excuse me. So we have 22,169. Why did I do that? Because if I go to this drop down, I don't see anything here that says between. So if you kind of remember from math class, when you had those number lines, something that's between two numbers, it's greater than one and less than something else. So we can see the number, and then we can calculate the percentage. Let's start getting into some of the questions that we didn't go through yet here. What percentage of decedents were born outside of North Carolina? Let's refer to the layout table. What percent of decedents? So let's figure out. All right, birth state. So we got this thing here called birth state right here. Which one is North Carolina? And I bet you it's probably going to be 34, but let's go through and double check on all these here as well. So we got this layout table, we got this guide, birth state. I'm pretty sure it's going to be 34. Let's just double check. Oh, okay. Codes for each outside county of residence. Refer to, okay, 34 for North Carolina. So 34 is North Carolina. So what we want to find is everywhere where it's North Carolina. This is especially important, and I just want to kind of make sure we've got the question. How many deaths were born in the state of North Carolina? Because a lot of times when we look at cancer deaths, if we just look at people inside the state of North Carolina versus outside, that's going to be important as well. Because a lot of times the factors which contributed to their death from cancer typically occurred outside of the state. So once again, we're going to do select by attributes. We're going to generate a brand new clause because this doesn't have anything to do with the other one. And so I'm going to look for something with birth state is equal to, and these are all the possible values that we have. So I'm going to click on 34 because that's North Carolina. I'm going to click apply. So make sure I got 34. And there we have. We have 65,701 were born out inside of North Carolina. How many occurred outside? And when we look at this table here, okay, and I want to focus on this table a little bit, this attribute table, I've got a little button here that says show selected records. So this will just show everything that's highlighted in blue. And I have something here called the switch. Watch what I can do here. I can click this little switch button, and now what we have here is everything is highlighted. All these records are highlighted that aren't a 34. 34s, not 34s. Okay, and this is something what we call a not, a logical not. That just switches it. Whatever is true is false, whatever is false is true. So I'm doing something here called a switch. Okay, so you can see here I run this, so I don't have to run an entirely new query. And the neat thing I can do here is now I can copy these to a clipboard, put these into Excel, put these into SPSS, so I can do this. You know, I can do my statistical analysis in another application. So these are really powerful tools, tabular tools right here that you should start to get used to. All right, next, how many cancer deaths occurred in Durham County? And we're going to focus on Wake County because I don't want to give the exact answer. So 7, 8, and 9, these are all going to be related to each other. So how many cancer deaths occurred in Wake County? You'll do Durham for your exercise. How many deaths are under the age of 50? And then how many of those deaths were people who were born inside the state of North Carolina? We already know what that query looks like. So this is what we call a spatial query. Okay? Now I can go through and look for the actual number that Wake County is, or I can select Wake County. Okay? A couple ways I can do that. If I know where Wake County is, I can literally just go and select it and see it highlighted. Because what I'm basically doing is I want to find all the green dots that occur within this polygon. So all the green dots within this polygon, because we're going to look at select by locations. And once again, select location by locations are going to be really kind of smart. Okay, really smart. But if you ask the computer the wrong questions, it's going to give you the wrong answer. So I need to select Wake County. There's a couple ways. One, I just went and grabbed it. Another way, I right mouse clicked and I went and labeled all these counties. And so now what did I do? I can just find Wake County, look for it, and grab it here. You notice here I've got these I have these things called slivers because the geometry of the data isn't all that great. But you know, I have these little slivers right here. Another thing I can do is I can right mouse click, I can clear it, and I can go just all the way down to Wake County. Let me look for it right here. Highlight it all the way to the left, and it's highlighted on the map because we have that one-to-one relationship. Okay, so now I've got Wake County. Now what I want to do is I want to find all of the cancer deaths that occur in Wake County. Now I can't do this using select by attribute, so I'm going to do something called select by location, and I'm going to do my input features. Now my input features are going to be cancer deaths that intersect with counties. Okay, so this is how it's going to read. So my cancer deaths that intersect with counties. I can do a search distance in degrees or miles. Is this a new selection here? But these are the different spatial relationships that we have. Cancer deaths that contain, have their center in, share a segment with, and are completely within. So we can look for polygons within polygons, streets entirely within counties, or whatever here. So I can look for all the cancer deaths within NC counties. I'm going to click apply right here, and look what we did here. When I run this, you're going to see there's 5,885 within, completely within. I get the same number. Intersect, get the same exact number here. So we can run a lot of these different types of applications and queries, and they generally mean the same thing. They might not necessarily mean the same thing when we're working with polygons versus polygons. You know, something that's within versus completely within, those are two different things with polygons that might occur outside, because zip codes don't coincide with counties. So we want to find all the zip codes that are within a county or completely within a county. Those are two very, very different things. Here we're working with points that are entirely within counties, and so these are relatively easy to do, relatively easy to understand. So completely within, I'm going to click apply. And so I've got all these points right here, all these green dots, which represent cancer deaths entirely within the state of, Wake County. You can see there's 5,885 of these. The next question I ask is, so that's one of the answers. The next question asks, how many of those are under the age of 50? Now I can go to my age units and check for everything under the age of 50. So now I'm going to do my select by attributes. But now I've got my cancer deaths. The input has a selection. Records to be processed, 5885. Do I want to do a new selection or select subset from current selection? And that basically means you're only picking from the 5885 instead of the 102,699, because we went through the trouble of picking everything out from Wake County. Next, we'll get rid of this one. We will build back to this one in a second here. So we want to see how many of these are under the age of 50. Age units is less than or equal to 50. I can click apply. Oh, not greater than, I'm sorry. Less than or equal to 50. Oops. Now, what did I do wrong here? I should just probably run a switch on this, right? I better run this again, huh? Alright, select by location, cancer deaths, apply. There we go. Alright. Alright, so is less than or equal to 50. So we can see 606. So we can see 606 people. And we can start to run statistics on these as well. You know, we can look for the high, we can look for the low, and kind of looking ahead to things, we can start to look at some of the information related to these, some of the descriptive statistics that we will start to talk about. Next, it says how many of these deaths were born in the state of North Carolina. So now I want to just select a subset where that birth state, BTH state, is equal to 34. Select subset from current selection. I'm going to click. Now remember the numbers from before. What's going to make sense? Is it going to be everyone? Probably not. Is it going to be no one? Is it going to be less than 606? It's better be. And so me, I'm probably going to say about 400, but that's just me. Probably a little bit less than that. I'm going to click apply. Oh, 253. So 253 people under the age of 50 were born in the state of North Carolina. And some of the things we can do later is I can right mouse click, go to data, export features. Now I can make this own brand new feature class. Instead of working with these 100 points, I can work with these 253 points right here and have these as their own feature class that I can work with. So these are relatively, relatively easy to do. We'll kind of circle back to the statistics a little bit, and then we'll get to the last question here. So we'll clear this. We can select by location, click apply. Now what did I just do right here? I didn't have anything selected, so what am I going to do? I want to select all deaths within all counties. Computer's stupid, so what's it going to say? It's just going to give me everything. So make sure you pick the exact county that we have. So we're going to do select by location, apply. And so now we've got these 5895. What can we do here? We can run some nice statistics on these. Let me look at some real basic statistics here, statistics that we all know and love. I can look at a histogram of age for the people who died of cancer in Wake County. Properties, hold on. Okay, yep, and I can look at the properties here. So I can see it's got a mean of 69 versus the data set is 69.7 versus 68.9. The standard deviation, the total number, the high. We can look at things called kurtosis, skewness. These are a little, bit different. So we can look at how cancer is versus the rest of the data set. And I can right mouse click on this, and I can export this data, export this graphic as a table, export it as a graphic that I can copy to my clipboard or do whatever I want to do. Now, what I'm going to do here as part of this table is I want to make a nice big table that tells me what county had the most number, because you can see Wake County had a certain number right here, the average decedent of age. We kind of looked at that as part of our statistics as well, but imagine going through and doing this for every single county, because I want to find the county that had the most deaths, the least deaths, the average age, because I bet you the average age at which people die of cancer by county is spatially related, believe it or not. It's kind of, you think of all this information, because right now we're looking at something that really doesn't make a lot of sense. It would be great if I just made a nice pretty map at the county level, and I'm going to get rid of these labels here, nice pretty map at the county level that had highest with the highest number, or average age or whatever, lowest with the lowest number, whatever we're trying to match, whether it's median age or whatever. So when we count, what we try to do is we're going to run something called the spatial join. And all it's going to do is it's going to count the number of points by county. Spatial join. Okay, we have something called a join where we use a key. With a spatial join, the key is going to be location. When we run a tabular join, the key is going to be attributes or columns that are common across both data sets. So we have something called the spatial join. And to run the spatial join, and I do have tutorials on it, I can right mouse click, and once again I'm going to have something called the join. I got to add join and then add spatial join. My add spatial join, my target features, my join features are going to be my cancer deaths, and then the join is going to be 1-to-1. I'm going to look for the word intersect, and I got some things here like fields. And let me look at what the question asks for. I want to find the average age of each decedent. And I'm going to go down to age, and the merge rule is going to be... Now, in my tutorial, I have a lot of neat things that we can do. Like I can go through and kind of literally like delete all these things here that I don't want to keep track of, because I can average all these up, count the number of males, count the number of females by county or whatever. So we really have a lot of capabilities or possibilities that we can do here. But I want to run something that's pretty direct, pretty easy. Oops. I don't want to show you exactly what I'm doing here, and hopefully, so mean, okay. So my target features are my counties, my join features are my cancer deaths, join 1-to-1. It's going to intersect. Basically, it needs to occur within. And I'm going to run this join here. Now, previous incarnations of our GIS software, we would create a brand new feature class that you would see showing up in our table of contents. But now, those don't exist. So now when I open it up, I've got 100 counties right here, and I'm going to uncheck everything. Now I go all the way to the right because I see the pop 2013, but I go all the way to the right, and I have something called join count and age units. You notice I went and got rid of all that other stuff because you would see a lot of other tables right here that are attached to the NC Cancer Deaths feature class. But for you, I was nice and kind of got rid of these. But now if I were to sort descending, I see a 5885. Does that 5885 ring a bell? Of course it does. That's the number of cancer deaths that we got from the select by location for Wake County and cancer deaths. And so now we've got this nice, pretty table right here that now I can go and copy this, paste this, and do whatever I want here. Now, what's this information ask for? It asks for just 1, 2, 3, 4, 5, 98, 99, 100, and there it goes. Now, I'm going to ask you to make a map, a professional map right here, okay? Yeah, I'm going to make a map out of this stuff, and we will. So you're going to fill in this information right here. Okay, so you can see this county right here. And we can go all the way down to the county that has the least. Tyrell County, Hyde County, Camden County have the least. All the way up the top, you can see we've got Mecklenburg, Wake, Guilford, Forsyth. Obviously, this doesn't mean all that much unless we start to look at, cancer deaths per population. So we have a Pop 2013 here. We can get more recent population dates if we want to look at these as well. But you get a general idea for your general cancer rates as well. And we'll talk a little bit more about those when we address normalizing data. So we can map these. I'm going to make a nice pretty graphic of the age units. And these age units look at the average age of each cancer decedent. So they range from 66 all the way up to 75. And like I said before, and giving you a preview for some of the things we can look at, I can right mouse click, we can sort ascending, sort descending, calculate field, but I can run statistics on these and just look at some real basic statistics. And once again, you can see the average age at which people die by county displays this kind of what we call normal distribution, which I think is really interesting and really unique and something that we as geostatisticians, biostatisticians like. We like looking at patterns like this. We can look at the properties right here, and we can look at the data set. Well, this is the entire data set right here, but we got the min, max, standard deviation. We can put these graphs on there. You can see this is very, very kind of even on both sides, or what we call symmetric, which I really like here. And then we can export these out and graph these and all that other good stuff. But we can also map these, because this symmetry is interesting. But we can also map these because part of the last question is make a nice pretty map. So I can right mouse click. Once again, when in doubt, right mouse click. I can click on symbology. I've got this symbology right here, and this symbology tab comes up. I can make single symbols, meaning I want to color in certain things. I can, unique colors just based on anything. But what we're going to do here is we are going to graph it using something called graduated colors. This is what we call a choropleth map. CHOROPLETH. Nice fancy word for just graduated color map. So we can do a graduated color map. We have all these drop downs. You notice with the spatial join we have a lot of drop downs. With the select by location we have a lot of drop downs. The power of a lot of drop downs is that you can do a lot of neat calculations and insights from just one dialogue. The thing is you can really mess stuff up really quickly from these and create not unpowerful insights, but misleading insights. And so we've got field here. I can go to my drop down here. I can go and map my join count. My join count is basically the total number of cancer deaths. Here I'm going to go down to my age units. I always think it's interesting, the age units right here at which people die of cancer are spatially related, spatially related. You would think that's a stochastic phenomenon, and it isn't. I have normalization. So if I want to normalize something, we'll talk a little bit more about this later, so that if I have something like my joint count and I want to normalize by POP 2013, here it is. Okay, so now we can see where the cancer rates are high and the cancer rates are low. Now these are just raw cancer rates, so you can see places like Watauga County, where App State University is, Jackson County, where Western Carolina is. They have a lot of young people there. So in essence, we're looking at the older counties right here, so we can do something called age grading, which is a pretty robust process, but we can normalize it as well. So, but here we're going to just look at the age units right here. We're not going to normalize because basically it's, I'm going to click on none right here. It's already normalized. And then we have a method. We have a method by which we create these maps. We create these divisions, because at the end of the day, who makes the map? Who determines these colors? Who makes the colors? There's certain colors used. There are certain colors used in choropleth maps that display different types of information. There's more internal contrast. And the method that we have. Me personally, I like doing something called quantile. Quantile basically means that each color appears the same number of times. And so there are some good things about it. There's some bad things about it. The good thing about it is that each color appears the same number of times. The bad thing is that your ranges are really skewed. So 68, 66 to 68, 71 to 75. This has got a range of 4, while this one goes from 69.46 to 70.19, which has a range of like 0.6. So the ranges of these values are different. Where that we have something called equal interval. Here's an equal interval map, but most of your values are going to be in the middle. So there's not a lot of highs, there's not a lot of lows, because when we see that normal distribution and it's symmetric and most of them are kind of centrally located about the mean and the median, that's where your equal interval is. So there's trade-offs to each of these. Me, personally, I'm just a big quantile person. And then you can pick the color scheme. I always like what we call color ramps. You want some type of color ramp right here. Okay, so something like this is useless because I don't know what high is, I don't know what low is, unless I'm referring to, the, I'm referring to the legend, where that I look at something like, I look at something like this, light green to dark green. I know that darker's higher, lighter's lower. I can refer to the units and figure out what they are exactly. Figure out what they are here. While I'm here, I can kind of go and play with the label. I'm not sure why they put these percentages in here. That's a little weird to me, because I don't think we ever articulated these were percentages, but I can change these labels. I can kind of delete some of these as well, because do I need like 5 and 6 decimal number precision here on a map? I don't think so. It kind of wastes a lot of time right here. But I'm kind of getting ready to make this map, because this is just a graphic here. I'm going to go with the greens. Colors like greens and purples have a lot of what we call internal contrast. So there's a big difference between green 1 and green 2, green 2 and green 3, green 3 and green 4, where people aren't going to conflate or confuse them. Where that your reds and your oranges, even your grayscale, doesn't have as much internal contrast, even though people love using grayscales because we know how much it costs. It costs to print out gray, or how much it costs to print out gray as opposed to colors. So I've got my nice pretty map right here, ready to go. Now, this is just a graphic here. What else does a map include? North arrow, legend, scale bar, maybe a nice pretty little graphic or something like that. And so what we're going to do here, and this is where it gets a little harder, and this is where the new software gets Now, I don't like the new software as much here, but when we look here, all we have is a map. When we start to print out maps, we save these towards layouts because I can click on the button right here, click on something called share, where I can export the map to a PDF. I can copy this thing to a clipboard. In addition, if I were signed in, I could export these all to my cloud so that I can share this with everyone and share this to the world and share it with computer screens or whatnot. Now, what I want to do is I just want to export this for a paper presentation. And so the skills attached to traditional cartography with north arrows and scale bars and all those other good things, it's still not a loss. Even though it's dying, it's still not a lost art. So I'm going to go to Insert, and I'm going to insert a layout. We print out maps on layouts, and we can insert multiple maps onto the same layout. This new version of GIS software probably isn't quite as nice, but we're going to print out 8.5 by 11. We can do letter, portrait, or landscape, but given the shape of North Carolina, I'm going to go to letter. So I've got a brand new layout right here. Now I'm going to go to map frame, and I'm going to go to my map, and I'm going to go on the map that I've kind of just clicked on. And so where do I want to put this map? Because I can, like I said before, I can put multiple maps onto the same layout. Because when you look at this layout is 11 wide, 8.5 high. What happens to be 8.5 by 11? Piece of paper. So now I'm going to put this map right there. This map that we've been creating right there. There it is, ready for me. Now, what else do I want on there? If I go to layout, I can go to something called activate, where I can kind of zoom in, zoom out, but it looked like the scale was nice and neat here for me to put it on, and so I'm not going to mess with it, but I can click on this button called activate and use these buttons over here so I can center it. I can change the scale if I want to zoom in or zoom out a little bit, but now I'm on the insert button here. Now I can insert things like a north arrow. Nice little north arrow right here. I can put a north arrow here. Here's my north arrow. So I know what direction is north. I can right mouse click and click on the properties. And now over here in my drawing order for my layout as opposed to my map, I can look at the properties for my north arrow. These properties, this property dialog is a lot different than the GIS software that I used for the previous 18 years of my life. So even now, in the past 4 or 5 years, I'm still getting used to it. But the border and the background, so I can change the kind of the background to it a little bit and then change the background to my north arrow. I can make it transparent or do whatever I want. Other things that I want to do is I want to add a scale bar. So I can add a little scale bar right here. To me personally, I think those of you who are really good with art and graphics, I think would really outshine me. Me personally, I don't have the artistic talent, nor probably the patience to go and make really detailed maps in this day and age. I'm more focused on the analysis, but I can I'll put a red background here with a little bit of a gap right here, and make it rounded or whatever. So there's a lot of possibilities that we can do here. We can insert a legend right here. I can insert a title. So, okay, here's my title. I'm going to put Tim's Map. Okay. And there's a lot of rules attached to kind of cartography, things like visual hierarchy and all that other good stuff. So I got my text symbol, appearance. I'm going to make it, let me make it a 28-point font, and then there it is. I can center this thing here. So this is Tim's Map. I can click on the map, hold my shift button, click on Tim's Map, and I can do a line center. So I moved it to the center. Now the center of the map right here. I have surround elements. I'm pretty sure I can insert pictures as well, graphics, logos. I can insert this legend. These legends get really ugly really quickly, but there we go here. So I've got my legend. Now I go down here, age units, NC counties. I don't want to call it NC underscore counties, so I can single click on the map right here, I'm just type in counties. There we go. That makes a little more sense. I can, instead of age units, age of decedent. Yeah. And I can put a background on that as well. I can look at the properties of these legends, and I can change a whole, I can change a lot of things, the way they appear, everything else. And so I've got a nice legend right here, something professional. So that now when I go to share, I can capture the clipboard, and I can stick this, I can stick this right into a, Word document or something like that. And I'm trying to just copy it and paste it into a Word document right here. So I've got a Word document right here. Oh, there's my map right there. In addition, share, I can print, I can export this layout. So I can export it as a PDF, export it as a TIFF. I'm a big person into saving stuff as TIFFs. I can change the resolution, because a lot of times with papers and presentations, they want certain resolution, because when you print it out on a poster, it'll get pixelated if you just kind of copy it off the clipboard or whatever. And so all these things attached to the graphics that you probably know a little bit more about than me, we can export these out. And then, like I said before, layout you can't export, but these maps, I can share these maps. I can share these maps. Share these maps as services, because when we share these maps as services, it'll create the title and the legend and all that stuff through the web app. So we've got something like something like this. We got insert. We can put charts, lots of different things right here. I thought for a second here that I could kind of drop and drag pictures right here. Let me try doing that real quickly just to show that we can do it. Oh, maybe not. There's somewhere here that we can insert pictures, dynamic text. So you might have to refer to the tutorial that I had in order to do that. But that's about it here. So for the last part, you just submit the map. So submit the map, capture the clipboard right here, and then under your exercise, you just go literally like down to the bottom. There it is. And so when you're ready for exercise number 1, we will submit this exercise, and all I'm going to be looking at is the Word document. So I'll just be looking at the Word document. I've provided a lot of other things right here to kind of help get you started. So when you get into death data, you got to kind of go through these detailed descriptions and layout tables. You'll notice there's some schema change right there, which really stinks, that you have to kind of match up or map, because they decided to change the names of things in 2013, 2014. And they also added some new qualifiers like tobacco use and workplace injury and other things, but at the same time they changed their name probably in response to some other standard change or whatever. So that's a good summary of exercise 1, a little bit verbose, but I wanted to kind of cover all of our bases, because I know we were a little tight last night with the introduction and then getting everyone logged on. And skip through this as you see fit. Last thing I'll mention, just make sure you're able to log on, especially those of us joining asynchronously. I don't want to hear, I couldn't log on or wasn't able to get on, in week 7 or whatever, because, the time's now. I've posted some, in the announcements, I will post some kind of general usernames and passwords if you're having issues with getting access to NCCU right now, and then we'll expect you to use those, because these are things that can be uploaded to your cloud. So I'll see you all on Wednesday, and have a great day.